So today we will discuss the preservation of pharmaceutical products using antimicrobial agents. So this is the learning objective of this session. After this session you will be able to understand, describe and write about the preservation of pharmaceutical products using antimicrobial agents. So we have already defined different terms like microbial spoilage. So we had defined it as an deterioration of pharmaceutical product by using or by a contaminating microorganism. So whenever there is a contamination due to a microorganism, that kind of product will show some kind of visible changes in the pharmaceutical products, and this is known as microbial spoilage. Now, in order to prevent this, we will use some method that is known as preservation. So preservation is the inhibition or inhibiting or minimizing the risk of microbial contamination, preferably during the storage and multiple dose application of the pharmaceutical products. So whenever you see any kind of products, especially those are in liquid state and which may be intended for single use or multiple use. So hope you know the difference between single use and multiple use. In case of single use, suppose we are going to use some kind of parenteral preparations like injections with an 5 ml. So the intention of that preparation is to use that 5 ml at a time. Once we broke the seal of that kind of injection, we will take all the 5 ml and we will inject directly into the bloodstream. So this kind of product actually we are preparing with the sterilization process, and we are ensuring there is no microbial contamination, and we are ensuring there is no chance for microbial contamination. But in case of multiple dose containers, suppose you are using an eye drops. So hope you know how to use eye drops. Once you broke the seal of eye drops, you may not use that in one time. You will use the eye drops, 2 drops QID or TID. That means you have to apply 2 drops to both of the eye on 4 times a day or 2 times a day or 3 times a day depending on the drug. So these kind of products, multi-dose containers, which is intended to use for multiple time once the seal is broken. So that kind of product are having a more chance of microbial contamination. So this kind of product has to be preserved by using some kind of preservatives. So that process of inhibition or minimizing the risk of microbial contamination is known as preservation. And the agent which is used for this inhibition or minimization of uh, risk of microbial contamination is known as preservative. And sometimes the preservatives, I have already mentioned, we require preservative in case of some kind of pharmaceutical products which are or which is there is a more probability of contamination of microorganisms. If you are using that kind of product or we are keeping for a prolonged time of duration of time, there is a chance of contamination. So that kind of product has to be used with the preservative. The product which are in solid, especially like tablet, powders, capsule, they are in dry form and there is a less chance for microbial contamination if we are keeping in a dry, cool place. Okay, so storage of every pharmaceutical product is very important. So if you are keeping any solid dosage forms like tablet, powder, capsule, etc. in an optimum storage condition, we don't have to use this kind of preservative. We have to use this kind of preservative for those preparation. Those have a good chance of microbial contamination like liquid preparation, parenteral preparation, multi-dose containers. And one more thing, if the parenteral preparation which is intended to administer the micro administer directly into the systemic circulation in large amount. For example, more than 100 milliliter. We should not add any kind of preservative into this kind of products. Those products in which or which are used to which are intended to use for and large volume into the body should not be added with preservative. നമ്മളെ ബോഡിയിലോട്ട് കൂടുതൽ വോളിയത്തിൽ ആഡ് ചെയ്യുന്ന ഒരു സാധനത്തിൽ നമ്മൾ പ്രിസർവേറ്റീവ് യൂസ് ചെയ്യാൻ പാടില്ല. And we have to use the preservative in multi-dose containers, which is intended to use in multiple times once it is opened. And also the uh, uh, we have to use this kind of product only for multiple dose containers and small volume parenterals. Okay. So now let's see what are the ideal properties on preservative. So you can think yourself what will be the properties of an preservative which is intended to administer into an human body. So it should be free of toxic as well as irritant effect. If you are injecting this into an human body, it should not cause any kind of toxic effect or irritating effect. It should be effective in preventing the growth of microorganism. The preservative should have an ability to inhibit the growth of microorganism, and the preservative should be soluble in water to achieve its adequate concentration in aqueous phase, because most of the microorganisms are grown in an aqueous phase, and it should have an adequate stability to heat as well as prolonged storage. So it should have a physical as well as chemical stability, and they should have a chemical compatibility with the other formulation of the component. So if you are using some kind of polymers in the formulation, uh, so it should be compatible, and it should not be adversely affected by the containers and closure. Sometimes what will happen is some of the chemical which is present in the containers and closures may reach into the formulation and it may adversely affect. So it should not affect with that kind of containers and closures, and it should have an acceptable odor and color. Irritating ആയിട്ടുള്ള ഓർഡറോ കളറോ ഒന്നും ഉണ്ടാക്കാൻ പാടില്ല, ആൻഡ് ഇറ്റ് ഷുഡ് ബി എക്കണോമിക്കലി ചീപ്പ്. എത്രയും ചീപ്പായിട്ട് വില കുറഞ്ഞ് കിട്ടുന്നോ അത്രത്തോളം നന്നായിരിക്കും. Now these are the classification of preservative. We can classify preservative mainly into four based on their chemical nature. Cationic detergents like benzalkonium chloride, alkyl trimethyl ammonium chloride. These are mainly used in the cosmetics as well as contact lens solutions. And another example of preservatives are alcohol, chlorobutanol, dichlorobenzyl and benzyl alcohol, phenyl and phenoxyethanol, 2-bromo, 2-nitropropane, 1,3-diol or pronopol. And third one is phenolic compound like chlorinated and isoprenyl derivative of metacresol. And fourth one is organic acid like acetic acid, lactic acid, citric acid, propionic acid, benzoic acid, salicylic acid, sorbate like methyl paraben, propyl paraben, etc. So all these are the classification of preservative based on the chemical nature. Now there is another example or class of antibiotic preservative which is used for some specific formulations. For example, in case of tablets, we will use methyl paraben with a concentration of 0.1%. And in case of parenteral preparation or injection, we will use phenol, cresol, benzyl alcohol, thiomerazole, methoxyhydroxybenzene. Only these are the official preservatives used in the injections. And in case of eye drops, benzalkonium chloride and phenyl mercuric nitrate and chlorhexidine acetate. These are examples of preservative used in eye drops. And now pronopol, alcohol, methyl paraben, chloroform, benzalkonium chloride, chlorocresol. These are the preservative used in syrup as well as mixtures, etc. And cresol, dichlorobenzyl alcohol, cetyl trimethyl ammonium bromide. All these are the preservative which is used in semi-solid preparations like cream, lotions, etc. So this is very very important for an pharmacy students to know about the different preservative which is specifically used in the specific pharmaceutical products. So this is mainly seen as an 2 mark or 5 mark question. Define and classify preservatives used in the pharmaceutical products. So please note this class or examples of preservative which is used in the different formulations. So that's all about the preservatives and its classification. Now coming to the factors affecting efficiency of preservative. So after this session you will be able to understand, describe and write different factors affecting the efficacy of preservatives. There are 9 factors: interaction with the formulation component, chemical structure and properties, effect of containers and packaging, type and initial level of contamination, effect of product pH, temperature of storage, presence of inactive agents like dirt condition, then changes of concentration and efficiency of multi-phase system. So these are the different factors. Let's see one by one. So first one is interaction with the formulation component. So as we are already mentioned, we will use this kind of preservative when they are in liquid state, especially for syrup as well as mixtures as well as parenteral preparations. So every kind of formulation here we have to use active pharmaceutical ingredient along with some other uh, excipients. Like in case of syrup, we will use sucrose, or in case of other kind of mixtures like elixirs, we have to use alcohol. So all this should be compatible with the preservative. So the example hydrocolloids such as methyl cellulose, polyvinyl pyrrolidone, alginate, triclocan, all these are the polymers which is mainly used in some kind of suspension or emulsions. So these have an ability to interact with the preservative. So what will happen is these kind of polymers will absorb some concentration of the preservative and it will diminish their action. ഈ പറഞ്ഞ പോളിമറൊക്കെ യൂസ് ചെയ്യുന്ന സമയത്ത് സംഭവിക്കുന്നത് പറഞ്ഞ പോളിമറൊക്കെ ചെറിയൊരു പോർഷൻ ഓഫ് കോൺസെൻട്രേഷൻ അബ്സോർബ് ചെയ്യും. അപ്പോൾ കോൺസെൻട്രേഷൻ കുറയും, പ്രിസർവേറ്റീവിൻ്റെ കോൺസെൻട്രേഷൻ കുറയും, അതിൻ്റെ എഫക്റ്റ് കുറയും. Then nature of the oil in water ratio and type of concentration also will influence the concentration of preservative in order to protect the system. And therapeutically, some agents like sulfonamides, kaolin, magnesium trisilicate, all these are in suspended forms in case of some kind of suspensions. So again, due to the absorption is a physical process in which the preservative will get absorbed or get physically attached into this kind of solid matters. So again, it will reduces the concentration and it will diminish the effect. So all these factors are the factors which will reduces the efficacy of preservative. Now coming to the second factor, that is the property of preservative. So if you are using any kind of preservative, it must be homogeneous and it must be soluble. Otherwise, its effect will be reduced. Suppose we are using some kind of polymers that is from natural source that have a chance for more microbial contamination. But we are if the preservative which we are using do not interact or do not combine with this kind of this kind of agents or solubilize with this kind of agents that will reduces its effects. And also sometimes there will be some leaching of some compound from the container and also it loses its antimicrobial activity. Now coming to the third factor, that is the effect of containers. Sometimes we have to use some containers which is made up of glass containers. Sometimes we have to use some containers which is made up of plastics. So the containers which we are using should have an ability to uh, penetrate. It should have ability to not interact with this the materials of these containers. It should not penetrate through the plastic container. It should not react with the rubber containers. All this will reduces the effect of the preservative. So these are the different factors which will affect the containers due to the penetration of the preservative into the materials of the packing containers. There will be some reduction of efficacy of preservative. Another one problem, if you are using some kind of screw capped containers or core, so these are the major source of mold as well as spores. So we must avoid this kind of containers while using preservatives because there is a more chance of contamination by spores. Now coming to the next factor, that is the type of microorganism. Some microorganism are originating from the soil, some are from the dust. Uh, so plant product which may contain some microorganism from the oil like Clostridium species as well as Bacillus anthracis, and some soil microorganism which may uh, common in dust, which may gain access to the pharmaceutical product during processing and packaging, and some product which may be infected by some animal or the bacteria from the animal source like Salmonella typhi. So these are the different type of microorganism which will reduces the efficacy of the preservative. Now next one is influence of pH. As we know, many of the preservative are weakly acidic or weakly basic. So these weakly basic as well as weakly acidic drugs will show their efficacy only when they are in unionized form. So benzoic acid, which is a weak acidic preservative, which will be effective only in unionized form. So if there is an acidic pH, it will be in an unassociated form and it will show its activity. If we are using benzoic acid as a preservative in a basic pH, it will not show its efficacy. ഇപ്പോൾ പ്രിസർവേറ്റീവിൻ്റെ ഒരു പ്രശ്നം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ പ്രിസർവേറ്റീവ് അതിൻ്റെ പി എച്ച് മാറുന്നതിനനുസരിച്ച് അതിൻ്റെ കെമിക്കൽ സ്റ്റെബിലിറ്റി മാറുന്ന ഒരു സാധനമാണ്. സോ വെൻ എവർ ഇഫ് യു ആർ യൂസിങ് നമ്മളൊരു പ്രിസർവേറ്റീവ് യൂസ് ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ ആ പ്രിസർവേറ്റീവ് ഏത് പി എച്ചിലാണോ സ്റ്റേബിൾ ആയിട്ട് നിൽക്കുന്നത് ആ പി എച്ചിൽ ഫോർമുലേഷൻ ഉണ്ടാക്കിയാൽ മാത്രമേ ആ പ്രിസർവേറ്റീവിൻ്റെ എഫിക്കസി കിട്ടുള്ളൂ. അതിൻ്റെ ഓപ്പോസിറ്റ് പി എച്ചിലാണ് പ്രിസർവേറ്റീവ് അല്ലെങ്കിൽ നമ്മൾ ഫോർമുലേഷൻ ഉണ്ടാക്കുന്നതെന്നുണ്ടെങ്കിൽ ആ പ്രിസർവേറ്റീവിൻ്റെ എഫിക്കസി അവിടെ കാണിക്കില്ല. So it will be in unionized. Benzoic acid will be unionized and active only in acidic pH. And another example, cationic active quaternary ammonium compound. They are active only in basic pH. If the pH is opposite, its effect will be reduced. So that's all about the different factors which will affect the uh, efficiency of preservative. And coming to the last portion of this preservative, that is the preservative efficacy test or challenge test. So this test is intended to evaluate efficacy of an preservative when we are using that preservative in its original unopened containers. ഈ ഒരു ടെസ്റ്റ് കേൾക്കുമ്പോൾ തന്നെ മനസ്സിലാക്കുക പ്രിസർവേറ്റീവിൻ്റെ എഫിക്കസി ടെസ്റ്റ് ചെയ്യാനുള്ള ടെസ്റ്റാണ്. ഈ ടെസ്റ്റ് വാലിഡ് ആവുന്നത് എപ്പോഴാന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ ഒരു ഓപ്പൺ സൊല്യൂഷൻ അല്ലെങ്കിൽ ഒരു ഓപ്പൺ ബോട്ടിൽ തുറന്നു വെച്ച് പ്രിസർവേറ്റീവ് ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ ടെസ്റ്റ് ചെയ്തിട്ട് കാര്യമില്ല. നമ്മൾ ഫോർമുലേഷൻ ഏത് പാക്കിംഗ് മെറ്റീരിയലിലാണോ പാക്ക് ചെയ്യാൻ ഉദ്ദേശിക്കുന്നത് അത് അങ്ങനെ പാക്ക് ചെയ്ത് അങ്ങനെ ക്ലോസ് ചെയ്ത് വെച്ചതിലോട്ട് ഈ ടെസ്റ്റ് ചെയ്യുമ്പോൾ മാത്രമാണ് ഈ ടെസ്റ്റ് വാലിഡ് ആവുന്നത്. Okay, so this test is applied to formulated medicine in its final container to determine whether it is adequately protected against the microbial spoilage. So from the definition itself, it's very clear. It should be in its final container to determine its adequately protected against the microbial spoilage. And this test is mainly used to demonstrate the efficacy of preservative in multi-dose parenteral preparation, ear drops, nasal drops, oral, topical and ophthalmic product which is made up with aqueous base or vehicles, not for any other kind of vehicles. Oily preparations ന്റെ കാര്യം ഒന്നും ഇവിടെ പറയുന്നില്ല. Aqueous preparations ലാണ് നമ്മൾ ഇത് പ്രിപ്പയർ ചെയ്യുന്നത്. Okay, Once again, this test is valid only to the product in its original unopened container in which it is supplied by the manufacturer. Manufacturer ഏത് കണ്ടെയ്നറിലാണോ അത് സപ്ലൈ ചെയ്യാൻ ഉദ്ദേശിക്കുന്നത് അതേ കണ്ടെയ്നറിലായിരിക്കണം എന്നുള്ളത് ഇമ്പോർട്ടൻ്റ് ആണ്. ഓക്കെ. Now, what is the culture media used for this preservative efficacy test or challenge test? Here it is, we will use the soybean casein digest media or any other media not less than the nutritive than the soybean casein digest media. സോയാബീൻ കസിൻ ഡൈജസ്റ്റ് മീഡിയ യൂസ് ചെയ്യാം, അല്ലെങ്കിൽ സോയാബീൻ കസിൻ ഡൈജസ്റ്റ് മീഡിയന്റെ ന്യൂട്രീറ്റീവ് പവറുള്ള ഏത് അതിനേക്കാളും കുറവല്ലാത്ത ഏത് ന്യൂട്രിയൻ മീഡിയം നമുക്കിവിടെ യൂസ് ചെയ്യാം. Now, what are the different official microorganisms, test microorganism used for the challenge test or preservative efficacy test? We have to use a wide range of microorganisms because there is a chance for wide range of microorganism as a microbial spoilage or contamination. So we have to use gram positive, gram negative organism along with the yeast as well as mold, which is specified in the Indian pharmacopoeial test. Now, these are some of the examples of microorganisms used for the challenge test. Staphylococcus aureus with a strain of ATC 6538. We have to use the specific strains of Staphylococcus aureus in Pseudomonas aeruginosa, E. coli, Candida albicans, and Aspergillus brasiliensis. So these are the different microorganisms used for the challenge test or preservative efficacy test. Now coming to the preparation of inoculum. So we have mentioned the name of different microorganisms. So the inoculum should have some property, or it should be prepared in such manner that it should not be not more than 5%. So what we usually do is, once we purchase a microorganism from a purchaser, we used to subculture that. But for a challenge test or preservative test, we should not use any microorganism that is subcultured more than 5 days. 5 പ്രാവശ്യത്തിൽ കൂടുതൽ സബ്കൾച്ചർ ചെയ്തിട്ടുള്ള ഒരു മൈക്രോ ഓർഗാനിസം നമുക്ക് യൂസ് ചെയ്യാൻ പാടില്ല. ആൻഡ് we are doing this to prevent any type of phenotypic changes in the strains. So usually there are two kinds of changes for a microorganism: phenotypic changes and genotypic changes. In case of genotypic changes, if there is any change in the gene, like in mutation ഒക്കെ സംഭവിച്ചിട്ട് അതിൻ്റെ ജീനിലൊക്കെ മാറ്റം വന്നിട്ട് മൈക്രോ ഓർഗാനിസത്തിൻ്റെ പ്രോപ്പർട്ടി മാറാം. Or otherwise, depending on the environment, there is a chance for changing the effect or property of microorganism, like in phenotypic changes. So we have to use any microorganism which is not more than 5 passages made from its original culture, and we have to prepare stock solution which has to be subcultured in soybean casein digest media, and we have to incubate this subculture in at a temperature of 30 to 35 degrees Celsius for bacteria for 18 to 24 hours. And if it is a fungus like Candida albicans and Aspergillus brasiliensis, at a temperature of 20 to 25 degrees Celsius for 48 hours for 7 days respectively. Okay, so these are the different duration of incubation for the inoculum preparation for preservative efficacy test. Okay, now we have to use, after this much incubation, we have to use this inoculum in sterile saline solution. We know normal saline solution with the 0.9% weight of NaCl concentration, that is a normal saline solution. So we have to prepare the inoculum in a normal sterile solution, both for bacteria as well as fungus, and we have to dilute with again sterile normal saline solution to get an concentration of 1:10⁻⁸ colony forming unit per ml. ഒരു ml എടുക്കുന്ന സമയത്ത് അതിൽ 10⁸ നമ്പർ ഓഫ് മൈക്രോ ഓർഗാനിസം അല്ലെങ്കിൽ കോളനി ഫോം ചെയ്യാൻ പറ്റുന്ന മൈക്രോ ഓർഗാനിസം ഉള്ള രീതിയിൽ നമ്മൾ അതിനെ ഡയല്യൂട്ട് ചെയ്യണം. For bacteria and for fungus also we have to dilute the Aspergillus brasiliensis in sterile normal solution, which containing 0.05% polysorbate, which is an surfactant which is used to homogenize the solution to get an uh, uh, growth of 10 raised to 8 colony forming unit per cell. So after alternatively we have to prepare the stock solution, and we have to harvest by centrifugation, wash it, resuspend in normal saline to give required to the microbial or spore count. So this is the official method of preparation of inoculum. Okay. Now, how can we do this kind of test in an product? Okay, so we will prepare some kind of multi-dose containers, which is we have discussed in the introduction itself. We may have to use preservative in multi-dose parenterals or eye drops, nasal drops, or some kind of topical preparation. So that will be with the preservative, that will be in the final container in closed state, right? So what we will do is we will add 0.1 ml of the prepared inoculum. We had mentioned the method of preparation of inoculum in the normal saline to get an concentration of 10 raised to n colony forming unit per ml. We are going to dilute the microorganism in that manner. So we have this inoculum or solution. So we will add 0.1 ml of this inoculum suspension into 20 ml of the product. So depending on the volume of the container or volume of the product, this value will change. So this is the ratio. For an 20 ml of the product, we have to add 0.1 ml. നമ്മളെ ഫൈനൽ പ്രൊഡക്റ്റ് 20 ml വോളിയം ഉള്ള ഒരു ബോട്ടിലാണെന്നുണ്ടെങ്കിൽ അതിലോട്ട് 0.1 ml ഇനോക്കുലമാണ് നമ്മൾ ആഡ് ചെയ്യുന്നത്. Okay, then the final concentration. So while adding the inoculum concentration is 10 raised to 8. ഒരു ml എടുക്കുന്ന സമയത്ത് 10 raised to 8 colony forming unit ഉണ്ട്. So after mixing with the 20 ml of solution, we should get an concentration of 10 raised to 5 or 10 raised to 6. അത്രയും കോൺസെൻട്രേഷൻ ഉള്ള രീതിയിലുള്ള ഒരു മൈക്രോ ഓർഗാനിസം സൊല്യൂഷൻ കിട്ടണം with the product. And once we added the solution, we should determine the viable number by plate count method. So we had mentioned, we had described the different methods for determination of count number of the bacteria. There are different methods for determination of viable number as well as total number. So plate count method is one of the method for determination of viable number to determine the number of live microorganisms. So again, we have to determine the concentration of viable number, and we will determine the final concentration of the microorganism per ml during 7, 14 and 28 days. Then we will calculate the percentage reduction in the colony forming unit. So this is the procedure. എപ്പോഴാണോ നമ്മൾ എക്സ്പെരിമെന്റ് സ്റ്റാർട്ട് ചെയ്യുന്നത് ആ സ്റ്റാർട്ട് ചെയ്യുന്ന സമയത്ത് we will add 0.1 ml to 20 ml of the product and we will mix it. Then we will determine the viable number at that time. Then we will incubate, or we will store the product in the storage condition which is specified for the product. And we will take the sample at 7 days, 14 days and 20 days, and we will calculate the percentage reduction in the colony forming unit per ml. So this is the procedure for preservative efficacy test or challenge test. Now how can we interpret the result? എങ്ങനെയാണ് ഇതിന്റെ റിസൾട്ട് നമ്മൾ തീരുമാനിക്കുന്നത് എന്നുള്ളതാണ്. So after this evaluation of 7, 14 and 28 days of evaluation of number of viable microorganisms, we can say the preservative is effective only if. എങ്ങനെ കിട്ടുകയാണെങ്കിൽ മാത്രമാണ് പ്രിസർവേറ്റീവിന്റെ എഫിക്കസി ഉണ്ടെന്ന് പറയാൻ പറ്റുക. In case of parenteral, ophthalmic, sterile nasal and optic solution, the concentration of viable microorganism is not more than 10% of the initial concentration in the 7 days and not more than 0.1% of the initial concentration at 14 days and further decreasing on 28 days. Okay. So why we are mentioning this? Because there is an increasing number of 10% in the initial 7 days, because in first phase of this experiment we are adding 0.1 ml, which containing 10 raised to 8 colony forming unit per ml solution of microorganism into 20 ml. So there is a large number of microorganisms. Then also it should reduce the number of microorganisms into 10% of the initial concentration. So that means with the effect of preservative, the preservative should kill 90% of the initial concentration. Okay. അങ്ങനെയാണെങ്കിൽ മാത്രമേ പ്രിസർവേറ്റീവിന് എഫിക്കസി ഉള്ളൂ എന്ന് പറയാൻ പറ്റുള്ളൂ. 7 days കഴിയുന്ന സമയത്ത് നമ്മൾ കൊടുത്തിരിക്കുന്ന സപ്പോസ് 100 മൈക്രോ ഓർഗാനിസം ഉണ്ടെന്ന് വിചാരിക്കുക. 100 മൈക്രോ ഓർഗാനിസം ഉണ്ടെങ്കിൽ 100 മൈക്രോ ഓർഗാനിസത്തിൽ 90 മൈക്രോ ഓർഗാനിസത്തിനെയും കില്ല് ചെയ്യണം. 7 days കഴിഞ്ഞ് നമ്മൾ വയബിൾ നമ്പർ നോക്കുന്ന സമയത്ത് അവിടെ 10 മൈക്രോ ഓർഗാനിസത്തിന് കൂടുതൽ കിട്ടാൻ പാടില്ല. അത്രയും മൈക്രോ ഓർഗാനിസത്തിന് മാത്രമേ ബാക്കി ഉണ്ടാവാൻ പാടുള്ളൂ. എങ്കിൽ മാത്രമാണ് പ്രിസർവേറ്റീവ് എഫിക്കസി എന്ന് പറയാൻ പറ്റുന്നത്. It's not over. After the 14 days, it should be not more than 0.1%. Due to the presence of preservative, again it should kill further 10% to 0.1%. Okay. അപ്പോൾ 14 ദിവസം കഴിഞ്ഞ് കഴിഞ്ഞാൽ ഇനീഷ്യലി 100 മൈക്രോ ഓർഗാനിസം ഉണ്ടെങ്കിൽ 14 ദിവസം കഴിഞ്ഞ് നമ്മൾ കോളനി ഫോമിംഗ് യൂണിറ്റ് മെഷർ ചെയ്യുന്ന സമയത്ത് ഒരു മൈക്രോ ഓർഗാനിസത്തിൽ കൂടുതൽ ഉണ്ടാവാൻ പാടില്ല. ആൻഡ് ആഫ്റ്റർ 28 days it should be decreased. So only if you are getting this result, we can say the preservation is effective, or the preservative is effective to kill the microorganism or to inhibit the microorganism. So there is no, in case of yeast, there should not be any increasing the yeast or mold count at 7, 14 and 28 days of preservation. So now coming to the topical preparation. Here we have another value for topical preparation made up of aqueous phase, non-sterile nasal solution or nasal preparation and emulsion. So it should not be not more than 1% of the initial concentration at 14 days, and it should decrease further on 28 days, and should not increase any number of yeast and mold 14 and 28 days in case of aqueous, non-sterile and nasal preparation, because these kind of preparations are intended for topical actions, like except the non-sterile sterile nasal solution. Almost all others are intended for topical preparation. So there is some relaxation in this number. So this kind of product, we can say the preservative effective only if we are getting not more than 1% of the initial concentration of the microorganism at 14 days and further decreasing the count. This is for topical preparation made up of aqueous base, non-sterile nasal preparation and emulsions. Now finally for oral preparation, so we know the property of oral preparation. Once we are administering any kind of dosage through orally, it has to cross different barriers of gastrointestinal tract. So first we have an highly acidic stomach, then we have an highly acidic uh, intestine, small intestine. So it is not mandatory to be sterile this kind of product, because we have some kind of protection from our internal organs. So again we have some relaxation in case of this kind of product. After 14 days there should not be not more than 10% of the initial concentration after 14 days, and it should decrease after 28 days, and there should not be any increasing yeast or mold count at 1 and 28 days from the initial count. So this is all about the preservative efficacy challenge test. So in this video we had discussed about the preservatives, type of preservatives, and different factors affecting the efficiency of preservatives, and the method for evaluation of efficiency of the preservative or preservative efficacy test or challenge test. So that's all about today. Thank you.